Hello, everyone. Welcome to the October fundamentals meeting of the Naperville Astronomical Association. Having a little bit of technical difficulties, but we'll get through it. In just a minute, I'll introduce our speaker. If you have any questions tonight, if you're watching on Facebook, just post them in the comments section, and our control room will read those questions off to our speaker, Ron, and then he will do his best to answer those for you. If you are watching on through our website, you can email questions@naperastro.org, and we'll get those questions forwarded to Ron also. So our speaker tonight is Ron Majors. Ron started astronomy imaging back in 2006 with a very modest 4¼ inch Newtonian reflector and various consumer cameras. And he was happy to capture brighter stars, the moon, and planets. And over the years, he's upgraded his equipment, and now he uses a 14½ inch StarMaster Dob with a ZWO Astro camera, and he uses SharpCap software along with the programs that I'll demonstrate tonight. Ron is a PhD analytical chemist, and he's currently innovating new surfactants for industry. And Ron has been part of the NAA since about 2014 or 2015. So Ron, we're going to hand things over to you if you want to share your screen.
All right, very good. And just checking audio, you can hear all right. And let me share my screen. And I will bring up my initial presentation. And Jim, can you please just confirm that audio is okay?
Yep, yeah, we can hear you.
All right, thank you, very good. Just want to make sure before I launch into this. So again, thank you very much for the opportunity to be able to present here. This is intended to be a practical, more hands-on session where I'll actually walk through some planetary image processing. And this is just one way in which it can be done. There are many. This is all taken from, and I have to give credit to a tutorial that was provided by David Richards, who posted in SharpCap forums. It's a UK originated software package that I use to acquire my videos and images, and a simplified overview to hopefully give you some tools that will allow you to make your planetary and lunar images look better. So this is my only slide before we actually go into the hands-on part. There's 4 simple steps here that can take you from what you see on the left, which is very commonly seen when you look through a telescope or some of the images that may be posted, to what you see on the right, which can be much improved. The first step is, of course, you must acquire your images, and you can acquire it as JPEG or TIFF or whatever the camera format is. But the better way to do it is to acquire video, so you can get many frames very fast. In the case of the ZWO camera that was noted, I'm able to take what's called raw image frames that are 16-bit depth. What that means is that the light to dark variation spans a very high dynamic range so that you can see subtle differences in intensity. Sometimes you might be limited to 8-bit if you use an AVI type format, and that unfortunately constrains you to just 256 levels, which when you're looking for subtle gradations and changes might make the image not look quite so good. So if you can do it, 16-bit raw video is the best way to do it. So in terms of the processing I'll show, we're going to start out with a program that's called Planetary Image Pre-Processing. And the pre-processing has a purpose to it. Number one, as you're tracking the object, it may not be centered in the frame, and this helps to do that. You can select that. And really important is to order the frames by quality. This allows you to then use the next program to slice off your best quality frames, because as the video runs and atmospheric turbulence occurs, differences in seeing over time, you may find that maybe your first frame, maybe your 10th frame, maybe your 300th frame are all really, really good, and a lot of the others are really bad. So this takes care of ordering it so that you can select that slice that's good. The next step is to feed the information into a program called AutoStackert. And what that does is that will create the image, and I usually put it into a TIFF format. But what it's going to do is it's going to analyze the frames, and if you've done everything right in step 2, you'll see a graph, and we'll see that in a minute, where the frames are ordered by quality. And then you can look at that and decide, hey, you know, I'm going to pick certain sections of it. And, you know, the more frames you have, the lower the noise, especially if it's a dimmer object. But you don't want to be adding in frames that are poor quality. And so as a result, there's usually an ideal balance between how many takes. So what AutoStack allows you to do is to, and we'll see it in a few minutes, to select up to 4 different slices. You know, it could be 1% of the frames, 10%, even 100% if you wanted. So that'll stack into images, and then we'll use Registacks. And Registacks is where some of the magic happens. It's a wavelet enhancement, and we'll look at that in much more detail so that we can sharpen features in a very specific way. It's much better than just using a sharpen function in a regular program. And I've given some starting values here that we'll see in a bit. Let me just bring these up and so that you can see them. You see what they look like, and you can see these links are live. This is posted in our Groups IO site. And so the planetary image pre-processing, and I'm going to have a little bit of a difficulty here with this. Just move this here in just a moment. There we go. AutoStackert, Registacks. Now let me go to my original one, and this will show you if you do access this document, it'll probably take you to a redirect, but it's the sharp cap. And this is a manual. So if you find what I'm giving you today is too basic, too elementary, there is so much more detail here, and it'll answer many questions that I probably can't. So again, thanks to the author here, David Richards, for showing us how to do that. All right, let's proceed. This is what PIPP looks like on your screen. And let's pull it up. What I want to be able to do is to share with you the most basic operations. And the first step of anything, starting on the upper left, is to pull in a file. But there's something down here in the lower right that's kind of cool. And we want to optimize options for this. Will pre-select the tabs and help it be easier for you. We're doing Planetary. Notice there's a lot of other options that are available. We're going to pre-select for Planetary. And then I'm going to add a source file. What's really cool about this is you can do it in batch mode. Now today I'm going to pull up Saturn, I think. So here's that SER video I was telling you about. And if we look at this a little bit more carefully, this is a 30-second video that's 1.125 gigabytes in size. So when you start talking about 16-bit video, it's much, much larger, approximately 10 times larger than if you had an 8-bit video. 8 times larger actually is. So let's go to selecting that file and open it. And I'm already given a warning here. It says there's a Bayer pattern that's been added. Well, what in the world does that mean? Well, a gentleman by the name of Bryce Bayer with Kodak came up with a pattern of pixels for color cameras that adds more green because that's what our eyes are most sensitive to. So we're going to de-Bayer it so that we can get a pattern that balances it out. So we say okay. And it's going to show the video. Wow, that really doesn't look very good, does it, for Saturn, especially for a 14.5-inch scope. But I have to tell you that seeing matters a lot, and who knows if this is the best frame. What we're going to do next now, though, is we're going to look at our different options. On the Input tab, there are not too many things you have to worry about unless you really want to get into some details that we don't have time for here. We're working with raw 16-bit video, so we really don't have to worry about those. Processing is where we begin to become concerned. My general approach is I don't like to apply any histostretching or gamma or gain or anything like that at this stage. I'd like to do that later. You can always experiment with it and say, hey, what happens if I do that? Especially if you see that first image looking really dim or over, if it's overexposed, you can't really do much about it. You can flip it if you want to be able to do that. But notice this is already selected. If I didn't select that item in the lower right corner earlier, I would have to select this. And we're doing object. Now, when would you select surface feature? Well, that would be if you're doing like a lunar landscape where the entire image is filled with features. Object planetary means you've got a bright object, and this is wonderful. You hover over it, gives you the help. So it works by detecting a complete bright object on a dark background, whereas surface feature is different. It's not the same. And if I had selected that, it would tell me what it is. Enable object detection. I don't really need to do that, but it's selected. I'm going to leave it that way. We can actually check and make sure, hey, are the settings okay to detect that object on the black background? The answer is yes, absolutely. So if that didn't happen, you might want to change the detection threshold. Center object in each frame. That's not pre-selected. I'm not sure why, but if you read the hover over, it says it makes the stacking software's job easier. I like that. So I want to center it. I really don't want to crop. There are times, like when I did my Jupiter one, you'd see the moon Io off to the side. And if I cropped it, I wouldn't get that. There's more features here. And yeah, if there is a frame that's overexposed, you can reject it. So, because an overexposed pixel is not going to work. I think from what you saw, mine was not overexposed. Okay, quality options. This is really, really important. I want to enable detection and reorder in quality order. That's going to make it a lot easier to do the slices in auto stackers. I'm just going to use a standard algorithm. You can experiment with other ones. What it's trying to do is it's trying to select frames based on contrast features and then sort them in order. We're going to go in forward order. Output options. No, I don't want to go to AVI. It always defaults to that. That's 8-bit only. I don't want to do that. I'm going to keep it as SER, so I keep my 16-bit. Because remember, that's the ability to detect differences in intensity levels among features. I'm going to keep the file source directory the same and create a subdirectory, this PIPP. It's going to make it easier to follow where everything is. So this is where it gets a little bit confusing because I just hit do processing and wow, something happened. Am I done? It says processing complete. No, that's just it running through the conditions that I've set up to make sure everything agrees with what I've selected. I do want to open the output folder from complete. So now I'm going to start processing. So here we go. Now it's actually doing the work. It turns out that in 30 seconds, I had 300 frames. That was limited by my computer speed. I was actually taking for this one 78 milliseconds per frame because Saturn's fairly bright. Jupiter was brighter as of 62 milliseconds per frame at my settings. If you have a smaller aperture scope, you're going to need longer time. Really important with planets while this is working, especially things like Jupiter. The features move along the surface quickly. Jupiter finishes a rotation in just under 10 hours. So in 1 minute, in 1 hour, it moves 36 degrees. And that's quite a long time. Now, normally the sorting frames by quality happens a lot faster than this, but something has locked up here. Okay, it's going, it's just slow. Hopefully we're okay. Yes, something was taking longer than normal here, and it might be just the bandwidth that I'm consuming. Let me, while that's working, see if I can do something and go back. Nope, we're just gonna have to wait, so I'll continue to talk. If you look at, say, the Jupiter Great Red Spot, you're gonna find that in a matter of a minute, it will have changed enough position that if you try to stack a frame that's more than a couple of minutes difference in time from your original one, you're going to deliberately introduce blurring, unless you use other programs that do what we call derotation, where it looks at each individual frame and says, hey, this moved by a couple of degrees, so now we're going to put it back where it was at the start and then stack. There are programs that can do that. That's outside the scope of our time here. I do apologize. This normally moves along a little faster. I think it might be because of the being on the live session, although we did do a test. We're only doing the one. So at this point, I just want to point out that the sorting by quality can take a little bit of time. It's examining every frame and running its contrast algorithm. It's also centering the object in the frame. We're moving along now. It won't be too much longer. Once we're done with this step, the next steps go fairly quickly. Again, the purpose of this pre-processing is to make AutoStacker's job easier. And in particular, when we go into AutoStacker, we're going to see a quality graph that will allow us to easily see, and we'll also get to see the video. And we'll be able to compare and say, hey, how is my best frame to my worst frame? And that also gives a visual indication, because sometimes what's best to worst quality may all be very good if you have excellent seeing. However, it's usually worth actually cutting out quite a bit of it. In fact, I think when we're done here, we may only take 30 out of these 300 frames. Every frame you add into the stack that is of poor quality will result in degradation of the final image. And that's where, if you're working with just photographs, images, whether they're TIFF or JPEG or whatever, or RAW, you'll want to physically look at every one of them and decide which ones are worth stacking. And that takes time. And I used to do it that way. I used to take as many images as I could. I might end up with 50 images, and I look at them, and before they're out of the camera, I've already deleted 20 because there were issues. Maybe there was a gust of wind that came by or something like that. And then I would take the remaining 30 or so back to the computer and go through them one by one and look and determine which ones are worth keeping and making those decisions. But it was all based on eye. Here we're going to have a graph soon that will allow us to actually make some quantitative choices. My experience with this PIPP is that it goes a little bit faster as it gets towards the end, because it takes a little bit more time to sort out the best, second best, third best. And once I get to a certain point here, I'm going to go back to my internet, if it allows me, and close a couple of those if possible. If I close a few of the tabs, we'll be in good shape. In fact, I might just close down. Nope. Okay. We'll go ahead and minimize that.
Hey, Ron, while we're waiting on that, I do have a question myself.
Yes, please.
So a 5-minute video is what I tried on Jupiter once. So you're saying if that 5-minute video, if I were to simply say start at frame 500 and to avoid any shake, and then end at, let's say, 1500, would that be, out of 20,000 frames, would that be enough to create a decent image?
If you have a 5-minute video, you're going to have to select 30-second segments that are all adjacent frames and look at each of those. So yeah, take as long of a video as you want, but when you're going to go ahead and do the stacking, you had better only consider frames that are within a certain time limit. So you could look at the first 30 seconds and just kind of scroll a 30-second window across all of your frames. But if you tried to take a frame at the end of that 5 minutes versus a frame at the beginning and bring them together, unless you have a program that does the derotation, you're going to be in some serious trouble. And again, I apologize about the slowness of this. This was not what we saw in the practice session. So Here we are. We're at 76%. We're getting closer. Did that make sense on that question in terms of the answer?
Yeah, thank you.
All right, very good. There's no reason why you can't take video across a large range of time. What I was hoping to be able to do when that question came up is bring up my Sky Live software abyss to show an example with, say, Jupiter and how much the Great Red Spot will have moved in just 1 or 2 minutes. But I think it makes sense. Now, Saturn, not so bad. And what about the positions of the moons? Typically, the revolution time of a moon around the planet. Yes, if you look 10 minutes later, you can tell that it's moved slightly, but that's not quite as restrictive. You still want to be careful, though, because you don't want to blur it just because you've selected 2 frames that are so different in time. Almost there, folks. And I'm asking myself at this point, is there a setting that I chose that's making this take longer than normal? But what you saw is what I normally do. So it's just deciding that my processor time is slowing down for some reason. And usually when that happens, you know where I look? I look down here in the lower right of the screen to see if my computer is deciding to download a Windows update or something of that sort. Almost there, guys. We're at 90%. Are there any other questions that come to mind while we're getting the last few percentages here?
I was just going to say, I'll ask another one, Ron.
Yeah, please.
Sorry. Do you know the name of some of those derotation software pieces? And are they free?
My brother, who lives out in Nevada and does even more astronomy than I do, told me the name of one of them. I think you just want to do an online search for planetary derotation, and I believe there is at least one freeware program. There we go. And now we see processing complete, and it truly is. It's supposed to remember open the output folder when it's done. We can go ahead and do that early here. And all of a sudden, in this same folder we were located, we see this new folder. Well, I'm going to go ahead and close this program. And let's just see, where are we at here? This is, I don't want to close out this session. So whatever that window is, I'm not sure about. We'll have to see, but I'm going to have to be able to move it to get my next program. I can reach them up here, I think. So under PIPP, what do we see? We see some logs, and the logs tell us a quality graph. This is just a notepad file. And this is numerical data. And you can see we ranged from 100% for the first one. It happened to be frame 147. And then you notice that frame 148 right after, and then we jump to frame 38. So they certainly don't follow in sequence, do they? And we go all the way down to 83. So that's quite a span of quality difference. I'm just going to minimize this, and I'm just trying to figure out what okay, here we go. That's just my right there. I'm going to close some of these and thinking that perhaps maybe having this all up was slowing it down. Let's hope. Next program, do you remember what it was? Is AutoStackers. And I'll do only 2 of the 4 slices just to make sure that we're okay. And it is taking its time. I'm just wondering if I'm getting a Windows update right at this time. Here we go. This is what AutoStacker looks like. There's 2 windows. One window is the file management and commands, and the other window is your image. Right now we don't have one, so we're going to open. And where did it go? Well, I'm going to go to where that folder is located, fortunately right on my desktop. And it's the Saturn folder. And remember, I'm not going to pull up this one. This was the one that was not quality ordered. The one under PIPP is. So I'm going to open up that one. Okay. Now, where is it? Well, let's move our sliders. And there we are. There's Saturn. What's really cool about this now is I can go up here to the top and say, hey, this is frame 1. Remember now, it's ordered by quality. So that's the best quality I've got right there. I can see the Cassini division. I can see some of the cloud bands, but wow, it still is kind of blurry, isn't it? But if I go to my last frame, wow, I can hardly even make out the Cassini division. So absolutely, there's no way in the world. This is just 30 seconds. I would never want to put that frame in. And I'm seeing this is what you would normally see. And definitely as I get back to frame 1, it's better. So that confirms for me that I'm okay. The options for AutoStacker are planetary or surface. Surface, remember, would be like the moon, or solar, or deep sky. Planetary is what I want. I still want to suggest a dynamic background because of atmospheric turbulence. As you saw, the image sort of shifted a little bit, even though it's centered. Turbulence will do that. And in terms of quality estimation, I'm going to use the standard default, which is a local. It's going to look around each alignment pixel, is what AP stands for. So the analysis step is step 2. And what it's going to do is it's going to analyze every one of those 300 frames. And this one, fortunately, goes a little bit faster. And it's going to give me a graph when it's done. And that graph will start at my 100% quality and move towards that 83% quality. And it'll show how it varies so that I can make some selections about my frame percentages to stack, which are on the right-hand side. So remember now, what I have is a video that is ordered in frame quality. And here we are. This is my quality graph. So this is my best, and that's my worst. I absolutely do not want anything to do with this last 1/4. These are sliced in quarters. In fact, I'm going to stay away from the entire last half. Let's consider what would happen if I took it at the halfway point. So I'm going to stack 50%, and I could choose individual frame counts. You pick either one, either tell it a number or give it a percentage. So it's going to stack twice. I'm going to tell it, let's take the first 50%. And that's probably not a very wise choice because this isn't that much better than that. Then I'm going to say, you know what? I'm just going to take that first, maybe 12%. And I could do more. I could pick 1%. I could pick 100. Do I want to sharpen it and do things like that? I'm going to stay away from any enhancements until I see what it looks like. Okay, so now it brings me, let me go back here a moment. How come I can't stack it? That's not enabled yet. Well, that's because I have to pick my alignment points. Now I could manually draw them, start putting them in there. And that's fine, and you can try that. I've had a great deal of success by simply placing an alignment point grid and choosing a minimum or maximum brightness. Now this image, remember, even though it's 16-bit data, the brightness still goes across the scale here, that like 128 would be the midpoint. If I say, hey, I want the minimum brightness to be, say, a 140 and place that grid, I get 0 alignment points. So I'm going to clear it. Let's try 105. Hey, I got a few right there in the brightest spot. That's not enough. How many points do I have? 26. Don't like that. When it comes to picking points, it's really important to avoid these dim edges. So a lot of times you might think, hey, I want to pick those points because that's showing where it varies along the edge. But actually, remember, there's some frames that are of lower quality that will have some turbulence. And in addition, there's not much in the way of features here. You really want where there's features. So I want to catch the Cassini division on each side. I want to catch the central zone. I'm going to bring it back down to 90 where I had it. And there we go. I have 74 alignment points across some critical points here that I like. You can do this manually, but you want to consult the manual. I've not had much success with that. I've always had more success doing it this way. Okay, they're placed. I'm now, guess what? I can now stack it. So what's this drizzle thing? I'm going to take that and turn it off because what drizzle is, you notice it says recommended. Drizzle is a function that you would use if your image is undersampled. What that would mean is you see pixels. In other words, imagine the image looked like these blue boxes. I actually have overdetermined data where I have plenty of pixels on my camera and I can see fine changes here. So I really don't want to do that. If you had a situation where some very distant object and your camera resolution was such that it was highly pixelated, you'd want to drizzle it. All right, I'm going to stack it. So remember, it's going to do 2 stacks. One of them using 50% of the frames, 150 frames to be exact, and another one using about 12% of the frames. What would that be? That would be around about 34, 35 frames, 36 frames, something like that. So in general, planets are bright enough. You don't need to stack more than a dozen or so frames before you lose the noise. And especially with the aperture that I'm using here, I could get away with probably stacking 5% of the frames and still get rid of the noise. What I mean by that is that an individual frame is going to have some camera noise and other sources of noise that when you stack the next image, noise is random, the noise will cancel, the actual signal will add, and you end up with a better image. Rule of thumb is you'd like to probably stack at least 8 images if you can. You can get to 16, that's best or better. So it did the first one, and now it's doing the second one, I believe. And we don't have too much longer to go. The registax actually happens pretty quickly. The MAP, what does that stand for? Well, that's the alignment points. And it's an analyzing the alignment points after it does the stacking and looks at them and determines are we good, and then repeats that. So we have 2 100% here, which means both have been stacked. And let's see what we've got. Let me check my folder. It's always good to have this guy open. And remember, I was deep within the PIPP. Let's just go back to the starting point. So I'm pulling up my folder. There's the PIPP. I did this within PIPP. So now I have auto stacker folders for 12 and 50. Let's look at the 50 one first. And hey, there's an image. Ta-da. Let's see what we've got here. I'm going to open this up with a program that I like. It's called IrfanView. I'm using a 64-bit camera here, or 64-bit computer. And that's not good. This is taking more time than it normally would. All right. There we go. Just opened it. And let's just take a quick peek at this. Maybe blow it up to 150. All right. Now, normally I'd pull up both at the same time, but we'll examine this and take a look. This is 50 frames stacked. We can begin to see some cloud bands, a little bit of the Cassini division. All right, let's go back up and we'll pick the one where we stacked 12%. And notice these are TIFF files, and maybe I just had to wait for the program to load. Yep, that's faster. I could probably do them side by side. So what my eyes observe, let me go ahead and try these side by side. What my eyes observe, let's see if I can just pull up that other one. Nope, okay, we'll do it from here. So 12 is on the left, 50 will be on the right. So we'll move it over. And we'll, come on. All right. We'll bring it up to the 150 as well. It's going to resize it. All righty. If you're looking at this from home, and look very carefully at how distinct the edges are, say on the Cassini division here versus here, we're going to pick this one here because I see a little bit sharper edges than I do there. The whole point of this process is to try to get the best data possible going into Registax. Also, too, if you look at the cloud bands, there's still a little bit of blurriness across these. These are starting to get a little bit sharper, and I can actually start to see some here versus I don't see anything here. All right, very good. So that's just sort of a visual examination to determine which one do I want to pull up. Remember, I pulled up the 50 on the right last. So we're going to pull up that that 12 there. So I'm going to go ahead and exit out of all these programs, so I'm not taxing the computer resources, and we're going to go into Registax. Now I've noticed there's an update for it, so I'm probably using a prior version of Registax 6. You might want to try this with the new one. Again, all these programs start you up in the upper left corner, and we're going to pull this up, and we got to make sure we go to the right place. So we go to our Saturn, member PIPP, AS12, and here we go. And it's asking me stretch intensity levels. Now, again, I'm gonna do that later. So this is the one we were just looking at. And what do we have here? We have wavelets, and we have a couple of choices. We can go linear or dyadic. Dyadic means 2 to the n. So let me explain what wavelets are. These are contrast enhancements of features across the image that start out very fine to coarser. Let me illustrate that, because you can press any of these buttons here on the right to preview it. And if I preview this, it shows you what the enhancements are, where red is decreasing, green is increasing. And what we have is some fairly large scale features. Whereas if I go to the wavelet layer 1, they're very fine scale features. Now, what is dyadic? Dyadic is 2 to the n. Well, 2 to the n means 2 becomes 4, 3 becomes 8. Let's just check that out. 8 is beyond anything on the other one. Wow. And if I continue on down, we don't want this, right? So when you're working with Registax, the advice that's given by the tutorial is start with linear, especially if you have a lot of pixels, and start down in the second and first wavelets. I think the recommendation is to start in the second one. I'm going to move it all the way to 100% enablement, and I'm going to sharpen to about 0.2. That's what's on my little 2-page tutorial. And watch what happens to the image as I do this. This is where the magic really happens. It's like, oh, this is too cool. Now it's starting to look like something. Wow, what a change. But notice how it's become noisy. Well, that's where we have the denoise, which is going to smooth that out. And again, we're working on a pretty fine scale in terms of pixel size here. And I find that usually around 0.2 and then maybe 0.4 is about right. If I over denoise it, it's going to start to get blurry again. All right, let's try wavelet layer number 1. Same thing. We'll just sharpen it on up. I could type in numbers, but I like to just see how it progresses. It doesn't take too long to get there. Well, that's fabulous. I probably don't need to get all the way to 2. Let's just let's go 1 more. And you can experiment with different degrees of doing this. And you can experiment with using the other layers. Not a problem. Now, the other thing is, when you contrast enhance anything, your saturation tends to increase. So we're going to have to do some color work here. That's looking pretty good. We can see the shadow, we can see the Cassini division, and I'll bet you if I've done this well, we might even be able to see the Yankee division out here. We'll see. But before proceeding, I need to say do all. If I want to undo any of these layers, I can just click the X and say, hey, that's what it looked like originally. What does that first one do for me? Should I just do that one? Or does the second one add more? I kind of like that. And I could test the third, fourth, fifth. Let's do all. And what it's going to do now is it's going to take the entire image and process it according to these parameters. You can save this scheme and give it a name and load it next time you run if you like it. Very good. Now we're just going to simply save it. I'm not going to write over the old file. I'm just going to type in R6. TIFF image selected. That's one of the higher resolution formats. It's saved. So because of the color changes, I like to bring things up in Digital Photo Professional, but there's something I've noticed about Registax 6, and maybe they fixed this. If I go to bring up that TIFF image in another program, there's a problem with that TIFF file that was just saved. And what we're going to see is a big question mark when I get there. Let's see. Let's go to desktop, Saturn example. Remember it was in PIPP, AS12. Oh, there it is. That's the one I want. I can't import it. This is before Registax. This is after. What's going on there? So that's where I like the surf and view. And watch this process here. I'm just going to open the program. I'm going to open my image, and this time I'm going to select the one that says R6. Hey, it's on the top. It opens there just fine. And then I'm going to File, just save it to the original folder with the same name, and it's going to save it with no compression. I suspect that Registax is doing something with compression or something. I'm not sure. It's going to ask me if I want to overwrite it, and I'm going to say yes. Good. Let's see what Digital Photo Professional says now. And there we have it. That was a little quirk that took me a long time to figure out. So I'm giving you that little heads up, and maybe the fixes to Registax 6 have helped. Now, if for those of you that are familiar with Digital Photo Professional, I can just go in to edit the image. I can make it bigger, a lot bigger, and look at all the color that's there. That's pretty awful. I'm going to adjust the saturation down some and do a few other adjustments. It looks like my my reds and blues and greens are a little bit too strong. I'm going to selectively work those down in saturation. Starting to look a little bit better there. Not a whole lot. Just play with it. Get it to where you're comfortable. Starts to maybe look like a planet now. And do I see anything there? Nope, I don't necessarily. Okay, that's fine. The other thing that I can do, there's a lot of things I can do here in terms of processing, but I'm going to go ahead and I'll do a little bit of extra sharpening here just to see what it looks like. And I can also reduce luminance noise and chrominance noise. And I'm starting to like this a lot. I'm just going to save it right there. I won't take up any more time. I'll give it time for questions. Convert and save. There's a lot of options available. I like to save a TIFF and a JPEG because the TIFF's going to be pretty big. The JPEG can be shared more easily. And for now, I'll give it an extension that shows I've processed it that way so I know where everything is. And we're done.
Ron?
Yes.
We have a question that's come up. It
Please.
says it says at this point, could you also be working in, say, GIMP or Photoshop?
Yes. So you pick whatever program you like. I'm very curious. If you don't do that step out of this version of Registax 6, do other programs have a problem seeing that file or not? But this is one way to fix it. But yes, you can use any of those. Let me just pull this up on the screen here. And again, you can do this however you want, but I just like this because then I know where everything is. And this is why are there two? They're the same? Well, they're not. That's the JPEG that's 550 kilobytes, and this is my TIFF that's 11 megabytes. So this is 20 times bigger. And I have another program I always like, for some reason, just for a different dimension of things. Whoops, come on. Different dimension of things. This Microsoft Office has some interesting features as well. And let's bring it up to like 150. There we go. And that is how we took Saturn from that blurry, fuzzy image to what you see here, as an example. Other questions, please? If there are any.
Say at this time, I'm not seeing any.
Okay. I find that when I process these multiple times, trying different things, sometimes it comes out a little worse, sometimes it comes out better. There was one time I was able to see a slight hint of one of the extra divisions in the rings. Very good. So just let's go back to the main slide deck. Oops, that's my picture. Close it for the moment. And again, this tutorial, these are available on the Groups IO site. I had posted, it's under a few other later posts. And then we're going from this type of an image to this type of an image. And that's true for lunar as well, if you select the surface features and lunar as opposed to planetary. And there are probably many other ways to do this that can result in images that are quite good as well. I've noticed that as you look at what some of the folks that are more well known for astrophotography do, they follow some of these processes, although I saw some fabulous images even just the other day, of Saturn stacked in Registax, not even going through AutoStacker. So, yep. All right.
I'll ask one, Mike. Again, another one of my own.
Please.
How different is this doing the planetary versus the moon?
I found that the process of going through it was almost identical in terms of the steps that I showed you. You just have to make sure you select the surface features and planetary and lunar, so that the programs are handling it correctly. But in terms of the checkpoints and the choosing of the fraction of frames that are the best quality, and then looking at your stacks of different quality amounts to say, hey, which one is better? Is it the one with fewer frames or the one with more? It's all the same process. The Registax can be quite different. It all depends on how many pixels are involved with the features of interest. So those different layers, layer 1, 2, 3, 4, 5, 6, etc. in Registax, are going to need to be looked at. And that's where it's beautiful the way you've set it up. You can preview it and get an idea of where your features are located. Are they in more towards the first wavelet, or are they more down further? And as we saw from mine, if I went to like the 8th one, it was horrible. We didn't even want to go there. So all the information was in the first and second wavelets, or maybe up to the 4th one. Lunar could be quite different. You might need to go into those higher ones, perhaps. All right. If there's any other questions, of course, they can be posted on the group's IO site. And one of the things that I offer to do for the members that may be watching is access through the group's IO information to request an example video to play with. You know, I started this too, by the way. Another thought is I pointed my camera into a dark room and took video, and then started putting that into these programs to see how the programs would just handle a normal image, and found that that was useful to do as well. So you're stepping away from the astro part for a little bit just to get comfortable with how the processing works in the programs. All right, at this point, I think I can stop sharing. Any other questions? Yep. Okay. So is it okay if I go ahead and stop sharing the screen at this point?
Chris, there was a few more questions.
Oh, great. Yeah, I don't want to stop sharing if there's questions that I can bring up the programs.
Okay. I'm trying to refresh and I do not see those. So if you have them, go ahead, Jim.
Yeah. So they're all from Bill.
Oh, hi, Bill. Did you try the video?
So he said GIMP had no trouble opening the TIFF.
Excellent.
Then, however, it converts it from 16-bit to 8.
Yeah. See, I think that's where the compression is the issue. And so Digital Photo Professional can work with the raw 16-bit, but it has to be that way. And somehow that IrfanView takes whatever Registax put out and corrects it back. So I'm hoping that the later version of Registax doesn't have that.
I noticed your version said like 2011, so you might be using.
It's old. I need to update. Just like I need to update my screen. You get used to using something, right?
And Bill said he's been working along with you on this, and he said that the Jupyter file was great to work with.
Fabulous. And just, am I allowed to bring up a commercial package like this Guy X from Software Bisque? Is that okay on the YouTube?
That's fine.
Because I just wanted to show the answer to that other question now that all the other things are closed, and hopefully it won't take too long. This will be pretty quick. It's just first light. And let's, yeah, I was hoping I would see this. This is all you got to do to see really good images, right? This was on the date that these were taken. Now let me go to Jupyter, which we know was right over here. There we go. And what I want to just illustrate is how much motion there is. So this is about where I was. The camera was tilted a little different angle. But watch what happens if I just move this 1 minute, 2 minutes, 3 minutes, 4 minutes. So you think about where that spot is. In fact, I can put this here if the cursor is visible, and just watch. There it is. I mean, right there, 1 minute is enough to blur it. Because if you're seeing features this fine, which the processed images from the videos I took can show that, there you are. You've blurred it, unless you have a derotation. And I suggest folks, I can post it on the Groups.io site once I see what my brother sent me, as far as the one that he noted that does the job. I don't think anybody's tried it though, so I'm hesitant to recommend anything without actually trying it. Glad to hear, Bill, that you were able to work with the file too. Any other questions?
I do not see any other questions.
All right.
Thank you very much, Ron.
Absolutely. More than welcome. Let me go ahead and stop sharing the screen then. And here we are.
All right. Well, thank you very much. Thank you, everybody, for watching.
Everyone have a good week.
Thanks, Ron. Bye.
Take care.